Okay, this is the M1 paper for October 2021. This is the last question, question 8. So we know it's going to be a relatively difficult question. And you can see it's vectors. More specifically, it's vectors where we're using the equation R equals R0 plus VT. So I'm just going to do 30 seconds of quick teaching to make sure that you're happy with what this formula means. What this formula means is if I've got my path of my ship here, what I want, or just any general vector, but what I want is R, where R can land me on the line somewhere. So all of those could be a general R that puts me on the line. Well, how do I work out any of those vectors? What we do is we say, if I know where it starts off from, and I call that R0, if I want to get to one of these R's, I'm just going to go that far along, or that far along, or that far along. Well, this is the velocity vector, and then that vector there is R equals R0 plus V. That vector there would be R equals R0 plus 2V. This vector here would be R0 plus V plus V plus V. So R equals, and generally R equals R0 plus how many lots of V? Well, it depends on your time. And obviously we could even go backwards with that. Right, that quick bit of explanation done then. It says ship leaves the port with a constant velocity. Good, there's my V. Position vector of the port is minus 2i plus 9j. Well, that's my R0. At 7:36, the ship is going to be at 4i plus 6j. So that means if I put time in here, I'll get my R working out there. We just need to be careful about this time then. As we can see from this part here, or just from our general experience, time is going to be in hours, kilometers and hours. So t equals 36. It's not t equals 36, it's t equals 36 over 60, or whatever that works out as a decimal, 0.6. Right, too much explanation. Let's actually get on and do the question then. So for part A, I'm going to say R equals R0 plus VT, and then it's just a matter of substituting in here. I've got that 4i plus 6j is equal to minus 2i plus 9j plus V lots of 36, in fact, I'm going to write 36 over 60 here, but in my next line, I'm going to call it 0.6. You can just do it 0.6 straight away. Take this over the other side. Okay, if I take that over the other side, I'm going to get 6i minus 3j is equal to 0.6v, which means that v will work out to be equal to, and I think they gave it to us in the actual question, if we look back, works out to be equal to 10i minus 5j. So that's the first part done. Part B then says, find the position vector of the ship t hours after leaving the port. Yeah, it's a relatively standard thing that we do here. What they actually want me to do then is to use that formula, and I know what V is now. So if I just do that, R is going to be equal to, well, let's put R0 plus VT again, just to explain what we're doing. But it's going to be equal to minus 2i plus 9j. And then I know V is 10i minus 5j times t. So that is the answer already done. I'd like to have it in the form AI plus BJ, simply because I'm going to be working with it in a minute. It's easier to have it as a simplified form. So yeah, you would get marks for that, but I'm just going to go one step further and say, what have I got with the i's? I've got 10t minus 2 lots of I, and I've got 9 minus 5t lots of j there. So that's part A done, that's part B done, and now for the rest of this question, it's a little bit trickier, but as we say, it is the last question in the paper, so that's fair enough. And what I'm going to do is very much make a use of a sketch for these two bits here. Have a read through of it, and what it says is it tells me that at 9:48 There's a lighthouse east of the ship. At 9 a.m, there's a lighthouse northeast of the ship. Where's the lighthouse? So what I've got to do first of all is to work out where we are then. And then a sketch, very much a sketch, should help me to unpick where the lighthouse is going to be. But let's at least, first of all, do where are we at 8:48 and where are we at 9. Remembering that at 8:48 and at 9, we started off at 7. So that's 1 hour 48, which is 1.8 hours. Well, that's just going to be 2 hours. That's slightly easier when we're doing this. So again, a lot of chat there. Let's actually just find out where we are and make it clear to the examiner. So at t equals 1 hour 48, which equals 1.8 hours, r is going to be equal to, so sticking 1.8 into that is going to give me 18 minus 2i, 9 minus 9j. All right, the j's are going to cancel. I'm going to get r equals 16i. Right, so if that's the case, really, really quickly, not taking any time over this, what did they say? They said that at that time, the lighthouse is east of the ship. So if the ship is here at 16i and the lighthouse is east of the ship, then that means that the lighthouse must be on the x-axis. If I called them the x and y axis here, I don't know where it is, but it's going to be on there somewhere. So that's useful. Part D says exactly the same thing, but with t equals 2 this time. So t equals 2 hours. R is going to be 20 minus 2 lots of I and 9 minus 10 lots of j. So now R is going to be 18i minus j. Right, what does that look like? Take a little bit more time over this one. So we're now saying, actually, let's just move that up here a bit. So if I'm going to sketch only relatively accurately, what we said before was we knew that the lighthouse was here and this was 16i. And what we're now saying is that when the ship is at 18i minus j, well, where's 18i minus j going to be? It's going to be there and there, isn't it? It's going to be 18i, more 2i further along, and a minus j down. I'm going to say that the ship now, whoops, is here, where this is 18i, and this is minus j. That at this point, what does it say? The lighthouse is now northeast of the ship. That's really, really important that it's northeast, because if it's northeast, what I can say absolutely accurately now is that if it's northeast on our compass headings is at 45 degrees here. It's the line y equals x if you want. It's 1 across and 1 up, 1 across and 1 up, 1 across and 1 up. Well, that's the way I'm going to solve this. Is now from my diagram here, if I'm trying to work out where the L is, I know that the 18 there and minus 1 there, this is where that second sighting of the ship is. If I just go across 1 and up 1, then I hit the lighthouse. So R for the lighthouse is equal to 19i, and I'm not really doing too much work beyond that diagram. So it's worth taking time to do the diagram and then being able to just sort of like across and up, across and up, across and up. And you might think that that's an unusual one, but no, actually that comes out quite often as a method for solving some of these bits and pieces. Sorry, this was all C, not D, so get rid of that. That's all part of part C. So there you go, that's that bit there. Really useful for you to see this question then in case they use that method again. They did use it for other vectors questions. And then part D says, can we find the position vector of the ship if it is due south of the lighthouse? So what we've got with the ship is the ship was there and was there. So it's going to be continuing to go down and hit here somewhere, and we're trying to work out what that is. Well, again, this is a fairly standard technique, that what we do is we say R equals R0 plus VT. Okay, so we know what the ship is. We know it's R equals 10t minus 2i and 9 minus 5tj. We've got that still. And all we want is, if it's at the point where it's south of the lighthouse here, the one thing that you can say about it is that at any point north or south of the lighthouse, the I component is going to be equal to 19. So we're simply going to say, we want I component to equal 19. So if the I component equals 19, then 10t minus 2 must equal 19. There's my I component. So we're going to get 10t equals 21, t equals 2.1. And now I'm going to put that in for everything. So I'm going to get R equals 19i, we've already got that, plus 9 minus 5 lots of 2.1. J, and then we just need to work out what that's going to be. So that's 19i minus 1.5j, and then that's the answer to where the position vector is when it's due south of the lighthouse. So just a quick reminder that all of that part there really did come from a relatively accurate sketch and a sort of understanding of what we're doing. Okay, difficult question, but hopefully that will make sense for you.